Hello students, today we are going to start with the topic from chemistry. So let's see what topic we are going to start today. The topic is chemical bonding. As you all know that we come across different substances and those different substances possess atoms in them. So how those atoms are linked with each other? They are linked by a linkage, a special linkage, that is a chemical bond. So the phenomena of formation of this chemical bond is called as chemical bonding. As you can see in this figure, like if I say these balls represent atoms, so you can see that how they are linked with each other. So this linkage, that the connection which is actually linking them together is a chemical bond. So we are going to take up the topic chemical bonding in this video. The topics we will be covering in this video are introduction of chemical bond, need of chemical bond, types of chemical bond, and we'll also take some tricky questions. So let's start with this topic. So the topic, as I told you, is a chemical bonding. As I told you that there are so many substances which possess atoms in them. If I say like we have these atoms, so and I'm telling you that they are connected to each other. So the connection that will connect them together is called as chemical bond. So let's study that what actually is chemical bonding. Chemical bonding can be defined as a linkage between two or more atoms in a molecule. As you all know that molecule comprises of atoms. Molecule comprises of atoms. Now how these atoms are linked? They are linked by a specific linkage that is a chemical bond. And the process of formation of this chemical bond is chemical bonding. As you can see in this figure, like if I say we have two atoms and the connections that are connecting these atoms together so that it can form one molecule, these connections are called as chemical bond. These connections are referred to as chemical bond. Now the question is, what is the cause behind the formation of chemical bond? Or we can say why atoms are combining with each other. See, atoms combine with each other in order to attain noble gas configuration. As you all know that everything in universe needs to attain stability. Everything in universe needs to attain stability. And for attaining this stability or a stable condition, what they do, they actually undergo a certain process. Like if I talk about atoms, in order to become stable, they have to acquire a noble gas configuration, which is actually a stable configuration, As you all know, like if I say, if I talk about sodium, right, we have done the atomic structure, you know the electronic configuration, atomic numbers and the valencies and all. So if I talk about sodium, and we know that the symbol of sodium is Na. We also know that atomic number of sodium is 11. And if I write its electronic configuration, it is 281. Now, this sodium is not stable because its first shell is complete, second shell is complete, but as far as third shell is concerned, it is not complete. It is having one electron. And we know that every atom, most of the atoms except helium and hydrogen, they obey the octet rule. That is, they have to have 8 electrons in the outermost shell if they need to attain stability. So this sodium can attain stability either by losing this one electron or by gaining these 7 electrons. Then only it will have its octet complete. Now it is easier to lose this one electron, right? So how it will lose? When it will lose an electron, there has to be certain acceptor to accept this electron. So that means in order to attain stability, it has to lose this one electron, right? But it cannot lose randomly. There has to be an acceptor. So if I say that sodium is losing one electron and there is certain acceptor which accepts this electron. So this will lose and this acceptor will accept, right? So the linkage of giving and accepting will lead to the formation of chemical bond. And that is the reason that after losing or after gaining, these respective atoms are attaining noble gas configuration. So this is actually the cause behind the chemical bond. I think you got it. So I'll just repeat it for you, that if somebody is going to ask you that what is the cause of chemical bonding, you need to say that atoms combine with one another to attain noble gas configuration, and by doing so they become stable. So this is actually the need of formation of chemical bond. Now the question comes, how atoms can achieve noble gas configuration? As I told you that they are combining because they need to attain stable noble gas configuration. But the question is how they can attain the noble gas configuration. So as we have discussed in the previous example, likewise I am taking a new example that they can attain this noble gas configuration either by losing electrons or by gaining electrons or by sharing electrons. So when they lose, when they gain, or when they share, this leads to formation of chemical bond. So this is the reason that why the chemical bond is actually formed. And when an atom lose or gain or share, it attains the stable state, that is the stable noble gas configuration. Now, what are ions? What are ions? We know that, like if I talk about atom, we know that atom is neutral. Atom is electrically neutral. That is, the number of protons, that is the number of positive charges in it, are equal to the electrons, that is number of negative charges in an atom, right? That is the reason atom has no charge. It is electrically neutral. But if in case, as I told you, that in order to attain stability, atoms either lose electron or they gain electron or they share electron, right? So when they lose or when they gain electrons, I'm not talking about the sharing part, please keep in mind. I'm just talking that when these atoms lose or gain electrons, they lose their neutrality. They no longer remain electrically neutral. Either they possess a positive charge on it, which is a result of losing electrons, or they acquire a negative charge on them, which is a result of gaining electrons. So when atoms bear a charge, whether it is positive or negative, this leads to formation of ion. Now they are not called as atom, they are called as ions. So I think it's clear. So if just an example, if it is written Na and somebody asks you that Na is an atom or ion, so you can see that there is no charge on Na. So that means Na is an atom. But if somebody asks you like this, that Na positive, what is it? Specify, it is atom or an ion. So as you can see the charge on sodium, that means this is sodium ion. Got it? So whenever there is an atom, it has no charge because it is electrically neutral. But whenever there is certain charge on an atom, it no longer remains an atom. Atom with the charge is called as ion, right? So as I told you that atom can lose electron and it can also gain electron depending upon its electronic configuration in order to attain the stability, right? So accordingly we have two types of ions. One is cation and one is anion. See, if an atom is losing electrons, it will form a cation. It will form a cation because after losing, it will acquire a positive charge on it, right? But if an atom is gaining electron in order to complete its octet, then it will acquire a negative charge on it, and it is called as anion. So cation and anion are the subtypes of ions depending upon that whether they have positive charge or whether they have negative charge on it. So I think it's clear that what is atom, what is ion, what is cation, and what is anion. So you can write like this. Atom, let's say if I write an atom, example of atom as A. So If the atom has a charge positive, that it specifies that this is a cation. And if I write like this, then atom is with negative charge, so it specifies that it is a anion. And if I write just A, that means it is not an ion, it's just an atom because it has no charge on it. Now let's discuss some questions and answers in order to see that have you actually understood the concept of atom or ion or not. So the question is, predict the cation and anion in the following. See, we have different elements given, or you can say we have different atoms given, and we need to see that whether they are going to form cation or anion, right? So we have sodium. If I talk about sodium, we know that the symbol of sodium is Na and an atomic number is 11 and electronic configuration is 281. So in order to attain stability, it will lose this one electron. It will lose its one electron. And after losing, it will acquire the positive charge because it has lose only one electron. That is the reason it will acquire only one positive charge. So that means Na has a tendency to lose electron. That means it has a tendency to form cation because atom with the positive charge is called as cation. Second, we have chlorine. So we know that the symbol of chlorine is Cl and atomic number is 70. So if we write its electronic configuration, it is 287. So as you can see that it already possesses 7 electrons in its outermost shell. So it is easier to accept one electron and complete its octet. So it has a tendency to accept one electron. So when it will accept one electron, it will form a negatively charged ion. That is Cl with one negative charge because it has gained only one electron. And we know that atom with a negative charge is called as anion. So chlorine has a tendency to form anion. Next we have argon. We know the symbol of argon is Ar and atomic number is 18. And what is the electronic configuration? It's 288. So in this case, you see that the octet is already complete. So that means it is a noble gas. That means it has already attained it is already a noble gas. That means it doesn't combine with any other atom because it is already stable. From cation, it will neither form cation nor anion. Next we have potassium. The symbol of potassium is K and atomic number we know is 19. So if we'll write its electronic configuration, it is going to be 2881, right? So as you can see that it has one electron in its outermost shell. So that means it is easier to lose one electron. And when it will lose one electron, so that means it will acquire a positive charge, one positive charge. So it will become K positive. So like sodium, again it is forming a cation. Now next we have is neon. Neon is something Ne. Atomic number 10. Configuration 28. So that means neon is also a noble gas because its octet is also complete. So it will neither form cation nor anion. So now we'll sum up the atoms and see that which out of them forms cation and anion. So sodium will form cation, chlorine will form anion, argon will not form cation nor anion, potassium cation, and neon will also not form cation or anion. So I think you got it how you're going to solve these kind of questions. Now the next topic is types of chemical bonds. So what kind of chemical linkage we get to see in atoms? So let's see that. So the types of chemical bonds can be ionic bond, it can be covalent bond, it can be metallic bond. So let's see what is the difference between these bonds, that which is called as ionic, covalent or metallic. So let's start with ionic bond first. See, ionic bond is that bond which is formed by transfer of electrons from one atom to another. Transfer means that one atom is losing electron and the other atom is gaining electron, right? So That means it is always formed when one atom donates the electron and the other atom accepts an electron in order to achieve stable configuration, right? So that shows that the atoms which donate electrons, we know, are always metals, because metals have the tendency to lose electrons, and the other partner which will be participating in the ionic bond should have the tendency to accept electrons, and we know that acceptors are non-metals. So that means this is a bond which is always formed between metal and a non-metal. It is always formed between a metal and a non-metal, because metal always donates the electron. It always loses electron in order to achieve stable noble gas configuration. And non-metal always accepts the electron in order to attain noble gas configuration. Like you can see in this figure, this is a common table salt which we use, that is sodium chloride. You know that sodium, that is Na, chloride, that means Cl. So Na and Cl, they are bonded to each other by this ionic bond. So let's see that how this bond is formed between Na and Cl in our common table salt. So let's take an example. So let's see how the bond is formed between sodium and chloride, or you can say sodium and chlorine. Chlorine, when combines, you know that it accepts electron, it acquires a negative charge, so it becomes chloride. So instead of writing chlorine, when it acquires negative charge, we use the term chloride. Otherwise, it is chlorine only. Like when it has started combining, it is chlorine initially, right? So sodium we know is Na, right? And chlorine is Cl. Now, as far as their atomic numbers are concerned, we know that sodium has the atomic number 11 and chlorine has the atomic number 17. So just let's write the electronic configuration: 281, and for chlorine it is 287, right? So we know that the atoms with 1, 2 or 3 valence electron, they are metals. So just write it down that sodium is one of the metal, and chlorine has 7 in its valence electron. That we know that the atoms with valence electron 5, 6, 7, 8, they are typical non-metals. So the elements with 5, 6, 7, they are non-metals. 8 is the noble gas, right? So metal and non-metal. So obviously the bond is going to be ionic in nature, because ionic bond is formed between a metal and a non-metal, because metal lose and non-metal gains an electron. So let's write here. So sodium is Na, right? Its outermost electron is 1. We are writing just the valence electron. It will lose this 1 electron. So I have written minus, that means it is losing 1 electron, and after losing, it acquired 1 positive charge, that is Na positive. Now let's write for chlorine. We know the valence electron is 7. So just put the dots like this. We always put this dots in pairs, like we prefer doing that. So chlorine initially possesses 7 electrons. It needs 1 electron in order to attain stable noble gas configuration. So it will accept 1 and it will form Cl negative. So what is the overall bond formed here? Na was having 1 electron, chlorine was having 7 electrons, right? And what they actually formed, Na positive and Cl negative. Now we'll crisscross their valencies. So when we'll crisscross, because there is +1 and here is -1, so as a result we get only NaCl, because 1, 1 cancel each other. So this is how the ionic bond is formed between sodium and chlorine, and this is how the sodium chloride is formed. So I think you got it. Let's discuss few more examples. Let's form the bond between this substance shown in a figure, which is aluminium oxide. So aluminium oxide, that means the constituent, that means the participating atoms are aluminium and the other is oxygen, right? So if we write the symbols, aluminium is written as Al and oxygen is written as O. If we write the atomic numbers, aluminium atomic number is 13 and oxygen is 8. Electronic configuration 283, electronic configuration 26. So that means this is a metal and this is a non-metal, because we can easily make out with their valence electrons. And we know that metal and non-metal, when they combine, they get linked by ionic bond. So how we are going to show this? We'll start with metal, aluminium, valence electron 3. So let's put 3 dots like this. It is going to lose 3 electrons because metals always lose. Now because it is losing 3 electrons, that means it will acquire 3 positive charge. Similarly, oxygen, it possesses 6 electrons. Let's put them in pairs. It will gain 2 electrons because it already possesses 6. It needs only 2 in order to complete the octet. So it will accept 2 and it will form O2 negative. So overall bond form is aluminium with 3 valence electron, oxygen with 6 valence electrons, and we get Al3 positive and O2 negative. Right? Please keep in mind, when you are writing on the left hand side, you need to write the plus because they are combining. But here they are already combined. You don't need to write anything in between Al and O or sodium or chlorine. Right? So we'll crisscross. So now when we'll crisscross, the valency of 3 will be here, written here as a subscript of O, and the superscript of oxygen, that is 2 negative. 2 is written as the subscript of aluminium. That is, the valencies get interchanged. But when we interchange these valencies, we don't make use of positive or negative. Right? We just use the numerals. So the required formula is Al2O3, which specifies aluminium oxide. So this is how aluminium oxide is formed. One more thing, like as you have achieved this formula, that is Al2O3, that represents that 2 aluminium combines with 3 oxygen. But we started with 1 aluminium and 1 oxygen. So after attaining this formula, what you can do is you can balance this bonding also. Like you have 2 aluminium, so just multiply this whole part with 2. Right? And similarly, you have 3 oxygen, multiply this whole part with 3. And similarly, you can write this 2 and 3 here also. So this becomes a balanced chemical bonding chemical equation. And this is the required formula for aluminium oxide. So likewise, you can write the molecular formulas for these ionic compounds, or you can actually show that how the ionic bond formation is taking place between these atoms. Let's do some question and answers. Which out of these pairs will form ionic bond? Now, when you get the question like this, so the first point that should strike your mind should be that ionic bond is always formed between metal and non-metal, right? And which elements are considered as metals? Those elements are considered as metals which have valence electrons 1, 2 or 3. And similarly, non-metals 5, 6, 7, even 4, they are non-metals. We don't consider 4 usually because 4, the element with 4 valence electron mostly participate in sharing, right? So that is the reason we exclude it. And 8 we know is a noble gas. It doesn't participate in bond formation because it is already stable. So we'll just keep these things in mind and we'll pick that which pair out of them is going to form the ionic bond. So first we have sodium and magnesium. So what is the atomic number of sodium? 11. And what is the atomic number of magnesium? 12. So if we write the electronic configuration, it is 281, and for magnesium it is 282. That means both are metals, and we know that metals do not form ionic bond. So that means this is an incorrect option. Second, we have chlorine and sulfur. Again, we'll write the atomic number. Chlorine is 17 and sulfur is 16. So if we'll write their electronic configuration, we'll see that both of them are non-metals. Again, non-metals do not form ionic bond. So again, chlorine and sulfur is an incorrect option. Third, we have sodium and oxygen. Sodium is with 11 atomic number and oxygen is with 8. So if we write the electronic configuration 281 and oxygen is 26. That means this is metal and this is non-metal. So this is our correct option because metal and non-metal combines to form ionic bond. So let's check out for this fourth option as well. Argon is Ar and neon is Ne. Argon is 18, neon is 10. If we write their electronic configuration, we'll see both are noble gases and they don't need to combine because they already have stable noble gas configuration. So which is the correct option? Sodium and oxygen is the correct option. Thank you. For more learning experience, you can visit www.gasex.com.